You know, just cover them, and
Okay.
if I have any questions, I under I've been using those calculators and how they
Yeah.
get there. I don't know. I mean, I can plug in numbers all day long, but understanding what's happening and interpreting the questions into like the ones I emailed you about the put it in words. I'm like, what are they talking about? So my answer
Oh,
was
well, that one, yeah, you did ask me that one. And I said, well, I can't really answer that one, but I can give you like hints about it. That's just going back to week 2, the definition of statistics. So let's start with that question really quick because I do want to get to the confidence intervals.
yeah.
That question, it's asking for what is the random variable in words. That's just asking what are they measuring? Because I look back at what you put, and you put 108 Americans. That's
Well,
called a constant.
just honestly, I just threw that in there just because it threw an error. I mean, it gives you a message.
No,
I didn't know
I
what
totally
to put.
understand. No, I totally understand. All they're asking you is what are they measuring? So, like, if I'm uh, asking about, if I'm going to survey, and this is the first example I'll do, I'm going to survey college seniors about their average credit card debt. So I pick 50 seniors. What am I asking them? What would be the random variable? What am I going to measure?
You're gonna have to show me. I'm honestly not. You're gonna let me get into the show. Just go ahead. Just explain it from the beginning. I guess.
No, I'm just what.
Credit.
So I'm just telling you the definition of a random variable is what you're measuring. So if I ask people, seniors, so suppose I want to find out the average credit card debt. So what am I going to ask those seniors?
Credit card debt. I guess. Huh?
Yes, yes. So that is your random variable. You're going to measure the credit card debt. That's all they're asking. You're not asking for anything else. They're just making sure you understand what you're trying to measure. That's called the random variable.
Okay. Okay.
So I'm gonna do. Let me do 3 examples and maybe more if I can get them in for each of the 3 types that you're learning in the first 3 sections, and then in each one I will ask you what's the random variable,
Okay.
and then maybe that'll help. So because this might take some time. So what I want to do is let's see. I have this is the first question. I want to know. Um, it's been reported that, and I guess I'm just gonna read this because it's gonna take me a while to type it. Well, I'll go ahead and type it. The average credit card debt is 3262 for college seniors. The Senate at that college feels that seniors have a much lower. Oh wait, I'm doing. Okay, I'm gonna start over here. That was hypothesis testing. I'm gonna just start with confidence intervals first. So let me do CI. Sorry, heights of 40 random men. That's what we're gonna study. So that's our sample. We're gonna pick 40 men and find their height. So what's the random variable here? What are we measuring?
The heights of 40 random men.
No, don't. That's the samples. 40 random men. What are we
The,
measuring? It's simpler than that.
the heights.
The height. That's it. And then if we want the X bar, what does X bar stand for?
Well, I know the var stands for a sample.
No. Example what?
It's the X. It's going to be the 40, isn't it?
Sample mean.
Sample.
See,
Okay. Yeah.
X is just the height. X is the random variable. X bar is the sample height.
Okay, this is the part that threw me off. So the X is the sample mean.
Mean. Sorry.
Okay,
No, X
and
bar is the
X,
sample mean height.
and the X is the sample.
X is the height. That's what you're measuring. X is your random variable. What are you measuring? You're measuring height of men.
The mean. Okay.
X bar is the mean of those heights. The sample mean.
Okay. All right. X is the height, and X bar is the sample mean of.
Yeah, you could just say the mean of heights is really the sample mean. So here, let's move on. This problem is, say their mean is 175 centimeters. Suppose we know the standard deviation of men's heights is 20 centimeters. And we want a 95% confidence interval. So there's three types of confidence intervals that we are studying. We're studying, is it just the normal one where the standard deviation is known? There's one where the standard deviation is not known for the population, and then there's a proportion. So this one is the population standard deviation is known. That's the first thing you have to decide. And that's hardly ever the case. I mean, in real life, we really don't know the whole population standard deviation. Okay.
And the third one is, tell me, so the standard proportion.
And that's where you're given a percent. So again, the first one is where we know the population standard deviation. The second one is we only know the sample standard deviation. We don't know the population, and that's the one that we usually use. And then the proportion. So those are the three ways that we find confidence intervals for our class. I mean, I'm sure there's a lot more out there, but these are the only ones we're covering. So we know that, okay? That is what we know. We know the standard deviation of any men's height is 20 centimeters. So we know the population standard deviation.
So we use that first equation rather than the second equation.
Yes.
Can you write that equation down?
Yes.
I remember that part from a video. If it's known, if it's unknown, we have to use the sample SD, and if we do know, we use the population SD.
Exactly.
Right.
That's the only difference.
This part I did catch. Now the EBM, that's a pain in my butt. I'm telling you, I'm not. For some reason, it doesn't click.
Okay, well here I'm going to make it click. Right now, we have to find the z-score that goes with 95%.
Yeah, the z-score that goes to 95% is a 1.96, right?
But I want to show you, do you understand why?
Yes. If you plug it in and you put 0 as this is why I don't understand it. I just know how to get it. You plug it into the calculator and you put 0 as the mean and 1 as a standard deviation. You get, and you do the between. You get, or I found not between. It's one of them, and you get the 1.96.
Right. You get outside.
Yeah, it's on the outside. Yeah.
Exactly. So you draw a normal curve, and you want to know. We want to know with 95% certainty that our mean, the true mean of all this, because we don't know what the true mean of every man's height is in this 95% interval. That's what we're trying to find. The true mean.
Right. Right. And if it comes out to like 99 or 90%, that number increases is like, I want to say it's like 2.1 something. And
1.645 for
yeah,
90%.
1.645. Yeah, that part I understand. 95%
Okay.
to 1.9. I
Well,
mean, I understand it. I'm pretty sure that I don't know if Tanisha, but she understands it. But
okay, well that just comes from last week 3. That comes
right,
from week 3. And I want to get through as many examples as I can so you can understand it. So
all right,
I will go back at the end and explain that more if we don't understand that. But that comes from week 3. 95% use the standard normal calculator and you get the z-score. And I'm going to show you where this EBM comes from too. I can show you where that equation comes from, but let's just get down to business now because we're almost done. We have 1.96 times the standard deviation over the square root of how many people. There's 40 in this group of men's heights. That's about 6.20. You should really go to 3 places. I'm just doing this kind of quickly. Yes, I'm going to do the t-value now. I'm going to do example of each one. This is not a t-value problem, Tracy. T-value is when you don't know the population standard deviation. So this first example is just using the where we know the population standard deviation. So now the confidence interval is just the mean plus or minus this error bound. That's EBM is error bound margin. So our confidence interval is 175 plus or minus 6.2. That means we're 95% certain that the true mean of the whole population is between those two values. Okay, and then I'm going to do the T next. But I want to show you 175 was in the problem. 175 is the mean that was given. I had to erase the original problem. So we know the sample mean was 175. That was given. Let me just say briefly. Remember we had the z-score formula, which was let's see, x minus the mean over the standard deviation. Oh, let me write it like this. I just want to show you where they're getting all these formulas from, okay? And what that did was change the standard normal curve to a normal curve. Okay, that formula, this z, changed where the mean was 0 to where our mean was something else. So if we do a little bit of algebra and multiply by the standard deviation on both sides, what we get is the standard deviation times z equals x minus the mean, because if you multiply the right side by the standard deviation, it cancels out. And then we add the mean to both sides. So what are we getting? We're getting what x is. So doesn't this look like what we're doing right now? We're taking the mean, and we're plus or minus z times our standard deviation over the square root of n. And this is the same question we had last week, where this comes from the central limit theorem, where we have to divide by the square root of n. Now that's beyond the scope of our book. I tried to send out an email about where they got the square root of n. But it's kind of hard for us to understand that because we're not covering every single little thing. But from the central limit theorem, this is what we're studying right now. And that looks just like what we talked about previously. So I'm trying to connect the two. if you know the z-score and you want to find your x-score that goes with it, that's what z does. It changes the standard normal curve to just a regular normal curve. That looks like what we're trying to find right now, the mean plus or minus your EBM. So this is the first 3 sections on how to do that. So let's look at another example. This is example 2, and I want you to tell me what the random variable is. Okay, let's take 10 surgery patients. And with the mean weight 240 pounds. Their example standard deviation is 25 pounds. Okay, so we want to find a 95% confidence interval. Now, I'm sorry my writing is so bad, but it's really hard to write on this tablet. Okay, so the first question is, do we know the population standard deviation? Yes or no? Do we know the standard deviation for all?
Say no. You have the sample deviation. You don't have this,
Right. So no population standard deviation. That tells you to use T. But it's really the same formula, right? I mean, it's really your EBM, or it's the error bound, whatever you want to call it. It doesn't matter the name of that. I don't really care about the name. But again, you're going to use T instead of Z. Now, again, it's beyond the scope of this book to figure out where they're getting the T's and the Z's, but there's tables that help us with this and calculators. So we're just going to use the table and the calculator, but it's really the same formula. It's the standard deviation divided by the square root of n.
Yeah, I mean that part I understand is if it doesn't clearly come out and say this is the standard this is the sample standard. If it says this is the sample standard deviation, then yes. I understand it. And if it says the population, I understand that as well. That tells me which one to select. But the part that I don't get is that it's not that clear.
No, not all the time. But in the homework,
you have to really understand. And the issue, I think, not just me, but other students get, is that you're doing this all online and you're having to plug in the numbers. And now if we were turning it into you, you would say, and I mean, it would be different. So you get marked wrong and you got to go back and do it all over again.
And that's why I want to encourage you, even on this section, if you take pictures of what you did, I can see right away what you did wrong. I don't mind checking that. I try to be online as much. I mean, I'm constantly online checking for questions. So that's, especially in this section, if you want to send me pictures of your work, I'll try my best I try to get back to people as soon as I can, or you can text to me. That would even get you a quicker answer, because I carry this stuff around with me and I can look it up right away. Especially at this week, because you're right. If you make one little decimal error, it's wrong.
Right, and it doesn't give you what you did wrong. It says, hey, look at this or reread the materials. Well, the materials is when you have one page of maybe 3 problems, is like what I'm doing when I was doing it. I don't want this to be about me, the whole thing. There's a number of people.
No, I totally understand, and I think what you can do is go through each section, and like section 2 will be T's. Section 3 is going to be proportions. You can depend on that, okay? They're not going to be mixed up. The only time they're going to be mixed up is in the knowledge checks, and I mean, I think it is pretty clear in the knowledge checks which one you should use. And if you're not sure, by all means ask.
Okay.
So let's go on with this. Since we know it's a T because we don't know the population standard deviation, then I'm going to switch this. I hope I don't lose anybody to the inverse T distribution calculator. So hopefully I'm going to share. Does everybody see that?
No, I don't see. Yeah, now I do. Yes.
Okay, so I'm going to use the inverse T distribution because I want to know what T is. So how many degrees of freedom am I going to put in here? And again, there's tables that figure all this out. There's calculus formulas that figure all this out, but we're lucky enough to have a calculator, so we can just look this up. How many degrees of freedom do we have here?
Simple. 10.
Okay, and then remember you subtract 1.
Yeah. No, okay. So you take the sample or their sample size and subtract 1. Right. Okay. So 9.
9. Yeah. So it's always n minus 1. You always lose 1. It's just for greater accuracy. And look at your confidence intervals right here. That's what you pick. If they give you 90%, you just pick the 90, but we want 95. That's the usual one. But be careful in the problems. That might also cause a problem. If they want 90, make sure you change that. And then all you have to do is calculate it, and there's our T value. So T, what we're going to use is 2.262. So let me go back to the whiteboard. Okay, can you see the whiteboard?
Yes.
Okay, so my margin of error is, this is just like your z-score. This is almost exactly like your z-score, but instead that we're using T. And you can do this all in Excel, but it's a lot more complicated in Excel. So I suggest you stick with, there's so many online calculators you can use. You don't have to use the one I suggested, but it's easier to use that one. And then there's standard deviation for the sample was 25 and n was 10. So this works out to be about 17.883, and I would take it to 3 or 4 places again. So our confidence interval, all we have to do is add that to our mean. So our mean was 240 plus or minus. That gives us the endpoints of the confidence interval. That means with 95% certainty that our population mean, the true mean of everything, is between those values.
Okay. Yeah. I see that. Well, there's that other calculator where you can throw the values in there and it'll give you the CI without a problem.
Yeah, that's true too. But I think I don't like to use that one that much, only because then I don't really understand where those numbers are coming from. And yeah. I mean, I know already we don't understand.
But I can spin my wheels of trying to understand it, or I can get it done. That's where I'm at. I can try to break it down and fully understand it, or I can get to the point that I can get it completed. And I'm at a stage right now is that I just got to get it done.
No, I understand that, but you have to do it over and over. You have to take the same problems and work them over and over and over, and it will help. I'm not sure people understand that. You don't just do it one time. I'm not just saying you. For me to learn all this material, I had to work these problems over and over and over again until I understood them. You're not going to understand them the first time.
No, no, and I'm not going to understand it after 6 week class. I can guarantee you that.
Yeah, probably. You're learning a whole stats book in 6 weeks. Yes, I do
No,
understand.
no, and I'm just going to get to the point that I can get the answers that I need and get them plugged in, and I could probably speak for a lot of other students and be able just to get through it. So, I mean, if you give me a way to, I don't know if I feel like I'm driving this whole thing, and I want to apologize to the other students, but that are in. I just, I don't know. I can go on about it for hours, but we don't
No,
have
I
that.
understand,
So.
and I don't know what to tell you because we're covering stats, and stats is a challenging subject. You can't believe me. If there was an easier way, I would be the one to tell you. I'm not trying to create hardship for anybody, but this is statistics, and if you pick up any statistics book, what I tell people is look at a statistics book. I mean, now I think the point is now that if you ever come across this, you'll have a way to, oh yeah, we covered that. Let me look back at that. I think that's some of the things you have to think about. That if you see this in the future, which I'm sure you will, some of this like hypothesis testing, then you'll say, yeah, oh, I know where to look back for that. And it just gives you a background. Alicia, I just did that one where the example. Oh, there aren't problems where the sample standard deviation is provided. If they should always give you the sample standard deviation, or they'll give you a table and you will have to use Excel to find the standard deviation. So if they don't give you the population standard deviation, those are two different things. If they don't give you the population standard deviation, then you use the t-value. So they have to give you one standard deviation, either the population or the sample. And if they don't give you the sample, they give you a table where you take it to Excel and figure out the standard deviation. So except on this problem, I mean, maybe you're talking about these problems. This is all you get. They say in a heart study, 1219 people were treated and 2313 were not treated. We're not on treatment. Okay, so the first thing you have to decide here, there's nothing else given. No standard deviation, no mean, no nothing. So what you want to do here is find the total number of people. So what's n in this problem? How would you do that?
I have no idea.
Well, if there's a certain number on and there's a certain number off, you're either on or off. So how would you find the total number of people that you asked or studied? We have the number on treatment. We have the number not on treatment.
The values together?
Yeah, you just add them together. Okay, so this problem, we want the confidence interval. Again, let's just use 95%. I mean, we can use any number, 90, 95, it would just change the z-value. But this is a proportion, so p prime is the percent on treatment. So how many people are on treatment? Well, that's 1219 out of 3532. and do it on a calculator, we get 0.345. Again, you should take these out to 3 or 4 places. This is a proportion problem. This is in the third section. So if you just joined us, you can go back and look at the recording. I'm doing one out of each section, an example. All right, so now I have P prime is 0.345. So my error bound, and I use P because it's a proportion, is Z times the square root of P Q all over N. All right, this is a little different formula, but it's not that different. So since it's not, this is normal. We use normal with proportion. So Z is 1.96. If it was 90%, you would use 1.645. And if it was something else, I'll show you that in a minute after I do this problem. So then I'm going to do the square root, and our P is 0.345. We can use that. 1 minus 0.345 because we don't have any other percent to use. And the total was 3532. And this works out to be about 0.016. So our confidence interval is the mean plus or minus our error. So our percent was 345, and we add plus or minus 0.016 to it. Now, when you work this one all the way out, what that means is 95% confident. We're 95% confident that the true proportion is between 32.9% and 36.1%. Because that's what this is. If you add 0.016, you get 32.9. If you subtract it, you get 32.9. If you add it, you get 36.1. So what I want to ask you is, that's one of each of the three. I can go over some more. There's an example. Somebody asked me to do example 1 in 5.2, so I could go over that. But I kind of want to show you where these z-scores are coming from. Again, let me share you.
Before you change to screens, so you have CI. I'm looking at that line right under the 0.016. Is that mean plus or minus the EBP?
Yeah.
You just have it substituted E for EBP, right?
Yes.
I think she's saying, is that the same as a 2D, 4D ratio? There she goes.
I don't know what 2D, 4D means.
I remember seeing that in the book before, or in the material. Okay.
Huh. I'm sorry, I don't. I'll have to look that one up. I don't know 2D, 4D. It was in one of the videos. Oh, I'll have to go look it up. That might be like a shortcut they're showing you. I'll look it up, and maybe like tomorrow I can explain what that is, 2D, 4D. But let me, again, show you where those z-scores are coming from. If I take a standard normal distribution, and we have to do the inverse, sorry. Let's go to the inverse. Inverse normal right here. And I want the area to be 95% in the middle. So I want 95% in the middle, and I want to know between, and it gives you the z-score. That's where I'm getting this 1.96. I want 95%. With 95% certainty, I want my true mean to be between these two values, within plus or minus 1.96 standard deviations from the mean. So if you do 90%, this is for the normal curve. If you do 90%, that's where they get the 1.645. 90% of the area is between plus or minus 1.645 z-score on a standard normal curve. If you want 93%, I mean, it could be anything. We just normally use 95%. If you use 93%, then you're going to use z as 1.812. Now with the t calculator, you have to know, usually it's 99, 95, 90. Now if they ask like for 93% confidence, then you'll have to use a different calculator. This calculator will only work for these 3 confidence levels. And then you have to know how many degrees of freedom, which all you do is subtract 1 from the number of people in your sample. So before I do let's see, let me go back to the whiteboard. Someone asked me, about this question. It was, let me quickly do this and then I'll leave room for more questions. Okay, example 1. In example 1, there were 15 people. And I'm going to leave time for you to work this one out without, maybe you don't know the answer to it. So let's do 95% confidence interval. And this was given. So what does X bar mean? If that's all that's given, what does X bar mean? Sample mean, great. So we know the sample mean. What is S? Sample standard deviation, yes, that's very, very important. That's not the population standard deviation. So this is the sample standard deviation. If they give you sigma, that's the population standard deviation. Okay, so that's the difference. We don't know the population standard deviation, so what do we use when you don't know the population standard deviation? Remember, we have three things. We have the z normal, we have the t, and we have the proportion. T's, yes, so we use t. So that's the first thing you should decide. Use z, t, or proportion, p. Well, it's not proportion and it's not z, so we use t. Okay, so go to the t inverse calculator. How many degrees of freedom do we have? 14 with 95%. Let's look it up. Okay, I'm going to go to my calculator. Let me switch screens here. All right, so I'm going to 14. Make sure you don't always keep it at 95. Okay, that's another thing. You have to read the problem carefully. If it says 90, I'm going to have to switch that. But in our case, it's still 95, so we'll keep it. So calculate it, we get 2.145. That's just like our z-score. It's not a z-score, but it's just like it. So we're going to use that. Go back. So we're going to do 2.145. Okay, that's t. And then the square root of, wait, sorry, 2.145. The standard deviation is 1.6722. Now, where did I get that? That was in the problem. Okay, that's the sample standard deviation over the square root of 15. And that comes out to be 0.924. So then all you have to do is take the mean plus your error. Your mean, it was given to be 8.2267. Okay, they already gave you that information, and then you just add 0.924. Now see how I'm going at least 3 places. So maybe, you know, make sure you can have an answer that's really close and it won't take it, but go at least 3 places. Okay, okay, right. So that means we're 95% confident that the true mean is between those two values. Okay, so I mean, these were a lot of examples. Does anybody want to look at something more specific or general, anything in general in this unit? Which do we use for proportion? Okay, that's what I was going to look at. Let me just look at a proportion problem. That's proportion is 5.3. Yes, proportion is 5.3. I think since I can't just make one off the top of my head, I'm going to pick one out of the homework. And then we'll go real slow on this to make sure you understand. No, I didn't do another example, but we could do that. Let's go back to Tracy asked to provide an example where we weren't using 95 all the time. So let's go back to this one. I can make this one up. The first one we did was 40 men, and we did their heights. And we found the mean was 175. And we found the standard deviation, and we were told the population standard deviation was 20. And in the first example, I said 95%. Let's make it 93%. So first, this is a z problem because we know the population standard deviation. So we do z this is your error, is z times the standard deviation divided by the square root of n, and that comes from the central limit theorem. So how do you find z? Well, it's not 95 and it's not 90. We know those values. We go to the calculator. We go to the normal calculator. So let me switch here. This one's the inverse normal. Let me go to the normal. No, we want the inverse normal. I'm sorry. Because this is trying to find the z-score with different means, so we want the inverse normal. That was correct to begin with. Sorry. So why we use the inverse normal is because we know the area is 93%. And the other one, we didn't have a place to put the area. So we're going to put 0.93, and we want it between, we want the z-scores for where that 93% is between, and our z is 1.812. So this picture shows us where we can be 93% confident that it's inside these two z-scores. So if it gives you a different, if you want 95%, 90%, you can use this calculator to get it, because this will give you any area. See, again, let me show you. 95% is between 1.96. That's why we use 1.96 all the time. Or if we want 90%, that's why we use 1.645. So it's easier to just kind of memorize those because we use those so much. But you can just change it. If you want 89%, that's pretty low, but you get different z-scores. Or if you want 99%, then you use those as your z-scores. You use 2.576. And this is true in the case of the proportion and the z-scores. So for t, you do something else. But for normal, which is the case where you know the population standard deviation, or for the proportion problems, you can use this calculator. So we want 93, so let's go back. So we're going to use 1.812 for our z. So let's go back to our, so E is 1.812. That's 93%. Our standard deviation was 20, and we had 40 men. And I'm going to use my calculator. And it comes out to 5.730. So our confidence interval for 93% would be the mean plus or minus your error bound. Our mean was 175, that was given, plus or minus 5.73. So notice the fact that, see, our confidence level went down to 93%. Before it was 95%. So we have less of a interval. Our interval got smaller because when we used 95% in our first example, we got 6.2 for our error. And that gives us a larger interval. So the larger our confidence level, the larger the interval. If you lower the confidence level, then our interval is going to be lower. And then let's look at like for t, if you go to the t calculator is right here. And for this calculator, we can only use 99, 95, 90, which is normal. But if it's a different confidence level that they give you for T, then you're going to have to use a different calculator. And you can just search. I mean, I'm sure we didn't ask you to do that, but in the future, if you have a different confidence level, which I truly doubt, but there are calculators out there, you just search for a T distribution calculator, and then you can probably change the confidence level. But for us, this is going to work. We're either going to do 99, 95, or 90 for T. Okay, so does that help? I know I'm going through this kind of quickly, but I want to get in as many examples as I can to answer your questions. Okay, great. Let me tell you, while you're thinking about things or questions that you have to ask, I would like to say, like, the next section, the 5.4, is just on type 1 and type 2 errors. So if you put the definition on a note card, proportion. Okay, let me do one of those. If you put the definition on a note card, then I will, it will make it much easier. It's section 5.4 is just a matter of knowing the definitions. Okay, so let me do a proportion problem. I'm trying to kind of make one up.
I have a couple questions.
Okay.
Okay, so next week for week 6, is it going to be anywhere as intense as week 5?
No. There's only one knowledge check. It's a lot shorter.
Okay. All right. I'm gonna email
something
you
different.
something offline and a couple of questions I have about offline. So about it. So all right, that's really what I was looking for. Okay, thank you.
Yeah, no, week 6 is going to give you time to study for the final. And the final's only week 4 through week 6. Okay, so this one is like one in the homework. Let's say 28 out of 65 freshmen declared a major. Now again, like week 2, I think it was, these problems change, so the numbers change in them. So if you keep putting the same answers down, that's why you might be getting them wrong. This problem in particular changes numbers for each time you try it. This one is a 96% confidence interval. So let me read the question. Out of a random sample, 65 freshmen at State University, 28 students have declared a major. Find a 96% confidence interval for the true population proportion of freshmen at State University who have declared a major. So calculate the error bound. All right, to 3 places. So we're going to do P prime. Oh, I know, week 2 was a long time ago. So your P prime would be 28 out of 65. And let's say that's about 43076. So we'll round it to 2 places because these are like percentages. So we'll say 43%. And we're going to use a z. This is a normal curve, okay? And then we have p times q divided by n. So 96% is a weird percentage. I don't know that off the top of my head, so what do we have to do? Since we're running out of time, I'm just going to go through this. You go to the inverse normal calculator. Proportion is always the normal calculator. You do the inverse normal because we know the percentage. So I'm going to switch this to my calculator. And we're going to type in 96. And it's between the z-scores of plus or minus 2.054. So that's the z-score you're going to use. You're going to use 2.054. Times 28 over 65. Well, that was 43%. So we'll just use 0.43 and then 1 minus 0.43. And then that's divided by n. So we had 65. So this comes out to be about 0.12615. What is Q? Q is just the opposite of P. So if P is, well, that doesn't make sense. So Q is 1 minus P. It's just the opposite. So if our P is 43%, our Q is 57%. Okay, so that's the error bound. And then if we want the confidence interval, we're just going to do the 0.43 plus or minus 0.126. Let's just say that. And that's going to be our, those will be our endpoints of our confidence interval. I shouldn't say equals here. These are just the endpoints. So that gives you these two values. I know, but that's my job, to make it sound simpler. So I'm trying to make it as simple as I can. And I know reading through this it gets you lost. I totally understand that. But like I said, my job is to make it simpler. And what I think what I'm going to do Thursday night is not spend any more time on the confidence intervals, because you have all these examples. I think I'm going to, even if you didn't get there, I'm going to do some examples on the hypothesis testing, and that's 5.5. And all you have to do is go through like 5 steps. If you go through the same 5 steps each time, then you will be able to get your answer. I'm going to try to make that way simpler. So I think unless you have you can email me all your questions and I will answer them. But on Collaborate, I'm going to get on and talk about the hypothesis testing tomorrow night, because I think that'll be a good chance for other people to watch the recording. So unless you have major questions, I will answer those separately, and then tomorrow night I'll do the give you some examples. I'll give you 3 examples of hypothesis testing. Don't worry. You let me just. How about if I just say this? Here are the steps before we go, so you can at least get started, because you're going to do these same steps on every problem, guaranteed. Number 1, figure out what A is. That's the null. Figure out what the alternative is, and they have to be opposites, okay? So the null always includes the equal sign. That's very, very important. I mean, maybe you didn't read this far and it might not make sense, but it will make sense later. Always includes the equal sign. So the null is going to either be equal, less than or equal, or greater than or equal. And it won't be hard to figure that out. So the alternative is just going to be the opposite of those. So whichever one, it doesn't matter what it says or the wording, whichever one includes the equal sign is going to be the null. Okay, 2, once you decide that, you find the z. There's formulas for these now. You find the z, the t, or z for the proportion. So each one of those 3 have formulas. So when do you use z? Well, when you know the population. The population standard deviation is not known for t, and for z, it's when you have like p prime or a percent. They're really easy to tell which one to use. So once you do that, find those using formulas. Put those formulas on a note card. Step 3. Step 3 is to use your calculator. Okay, again, I'm going to step 3 for z. Use the normal calculator, not the inverse. Use the normal for z or proportion. For t, you use the t distribution calculator. And what you're finding is you're finding the probability. You're finding p. It's a probability. P low, null goes. You reject it. P high, null stays. Okay, again, I know you don't understand where this is coming from, but you will when you read it. And then 5, you just say there's evidence to support keeping the null or to reject the null. And then you just fill in your own words. Okay, so there's 5 easy steps. They really are easy. It's the wording of everything that's going to get you. But if you follow those 5 steps for every problem, it will get you to the answer. You also have to decide, okay, there's one other thing you have to decide. Let me go back up here. You have to decide in the beginning, in step 1, let me go back to step 1, if it's left-tailed right-tailed, or two-tailed. And again, that's easy. If the alternative hypothesis is less than, it's left-tailed. Greater than right. Equal or not equal, it's two-tailed. So what I mean by that, a left tail, you're just looking at the left. The right tail, you're only looking at the right. Two-tailed, you're looking at this side. So it could be less than or equal to. Okay, so that's just a brief overview, and I know it's fast, but that's what I'm going to do Thursday night. But send me your questions until then, and I will try to answer them. And thank you for joining. All right, so continue to email me your questions. Well, thank you for coming on. Okay, thanks, Robert, for joining. Thanks, Tanisha. Thanks, Carly, and everybody that came on.